So I'm on slide 5, and this is the book Number Talks for Fractions, Decimals, and Percents. It is a fantastic book with exactly what you need for each number talk, and it will walk you through, like, hey, if you're doing addition with fractions, here's some different ones you want to do. And by the way, this is how you talk about repeated addition and repeated subtraction and how it deals with multiplication and division. So they're very specific, lots of lessons already done. And one of the ones we're doing today comes directly out of it. So join me on slide 6. You will notice I have the word student everywhere because I wasn't really sure who was going to be here today. But if you would take over one of those boxes and type your wonderful name in instead of the word student. So anywhere it says student, erase that and put your name in. Hello, if you're just joining us, we are on slide 6 and we're replacing our name where it said student, so we have a box. And at this point, you're gonna only change the colors. I'm gonna be the one typing on the slide. So just use the color codes. And the way we're gonna do this is, if you think you know the answer to 2 minus 0.59 or 59 hundredths, you're gonna change your text box to red, because red is the first color on the rainbow. If you think you have a solution, you're gonna turn it red. And take your time with this. I'm going to ask a couple people their solutions, and usually with students too, we'll have some misconceptions in there, so feel free to throw out a misconception also. Martha, what is one solution that you thought of, or a misconception? Just the number answer is what I need right now.
Well, I wrote down what I'm pretty sure is the correct answer, but I know a misconception is to not have that decimal. They forget that there's a decimal in the 2 and that there should be 2 zeros. And oftentimes they will bring that 5-9 straight down.
So what might their solution be with that misconception?
Let's see. They might put, if they remember the decimal, they might put 2.59.
Cool.
But, that would be a misconception.
Perfect. Gail, let's hear from you. What's a solution or misconception? What could the answer be?
So the answer could be 1 in 41 hundredths.
Wonderful. Let's call on Joanne. What's a solution that this might be?
I had the same one of the 1 in 41 hundredths.
Cool. Lovely. Let's hear from Raha.
Teresa, I think it's 0 in 57 hundredths.
All right. And at this point, if you have a solution that I did not put up here yet, would you change your text box back to white? If there's a number that you had that's not up here yet. Let me see if there's anyone else with one. Sonal, go ahead and tell me yours. And can you tell me, did I say your name correctly? It's important to me.
Oh, thank you so much. Yes, it's Sonal. I would imagine the kids saying 0.39 as well.
All right, 0.39. I don't think I saw anyone else. All right, so we have some potential ones up here. Martha's got another one. Go ahead, Martha.
I'm sure you all see kids do this all the time. They would look at that 2, and then they would look at that 0.59, and they would think that the 0.59 is bigger, and they would reverse them.
Oh, so what's the solution you would have?
They would probably 0.57 if that hasn't been. Oh yeah, that was mentioned. Never mind. Sorry.
Oh, it
But
was
that's what
mentioned,
they
so
would
that's
do.
all right. You can go ahead and agree with that. All
I
right,
agree.
so we've got 4 up here. And now it's going to be time for you to start to color code. If you think you know the right answer and you have a rationale for it, you're going to change your box to orange. And then if you're feeling clever and you can think of another way to show it's the right answer, we're going to go down the rainbow. Next color is yellow. And if you have a third way of thinking of it, you're going to change it to green, a fourth way blue, a fifth way purple. How many ways can you show me the right answer? And Dan, we'll start with you. Everyone else can continue with your color codings here. Dan, how might you solve this and what do you think the correct answer is?
Yeah, I think the correct answer is, 1.41. What I typically like to do is with any kind of inverse, it's always trickier than the straight up way of doing it. So I would do it in terms of addition. So instead of saying, okay, 2 minus 0.59 equals what, you say 1 plus what equals 2. Right? That way you're thinking of it more additionally. That's one thing I find sometimes is helpful. So it's essentially algebraically it would be 2 minus blah 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 equals x. So then you move it around to be what would it be? Yeah, that might be more complicated. So a lot of these things, obviously, I kind of think about it without doing it. So it's always trickier with kids where it's a new concept.
Yeah, so take your time with this one and try and verbalize it. So I think you started off with this 1 plus something equals 2. How would that help you to get to that answer of 1 and 41/100ths?
Let's see. I'm gonna have to think about this because I did it all in my head, so I'm not sure.
Neat. All right, well, let's go ahead and have some time to think about that one. Dan, I'll come back and we'll see if you've thought about that one even more. Let's see, Meg, tell us about which one do you think is the right answer and what is your process?
Hi. So I think that the final answer is 1.41. Thank you. And I found a different method to do it with online recently, and I thought this was a great opportunity to try it out. It's called Exploding Dots, and would it be okay if I turn on my camera? I think that would be the easiest way to show it.
Sure.
Just waiting for it to let me turn on the camera. Sorry. There we are. I think. Yes. So can you see my notebook okay?
Mm-hmm.
So how it works is that the black dots represent like one positive numbers, and the open circles represent negative numbers. So the way that you think about it is that, like, if a closed circle and an open circle come in contact with each other, they explode and just disappear. They're like a bad magnet reaction. So the first box represents the whole numbers for the ones place. Then the next box to the left represents the tens place, and then the hundreds place is for the next one over. And So what you do is you need to unexplode one of the black dots the into the cell where you have the negative 5/10, and like it. I could share a video that would help explain it more, but it's kind of cool, and you end up seeing that like those 5 dots get replaced by 5 dots more, because I mean like 5 whole dots, because the you ended up with like 10 coming in and then subtracting the 5 out, and then you unexplode 1 dot and you end up with 1 dot left, and so that ends up being a very visual way of seeing the problem. And I just thought that was a good one, especially for students that might struggle with English, for reaching students with another way than what we were traditionally taught about it.
So, and that's a great little app. I have a link in the chat to Exploding Dots if anyone is curious about like what was that. It's a great way of doing some regrouping. Thank you, Meg.
Thank you.
Let's see, Colette, let's hear from you. What did you find and what was your reasoning? Can you walk us through it?
Good morning, Teresa. I actually did it in my head because I'm really pushing myself to do that and encouraging my students to do the same. And I just looked at it as, okay, 59 hundredths. Ignore the 9 hundredths right now because I know that 50 hundredths or 5/10 is half. So I took half away from the 2, which gave me 1.5 or 1.5. And then I'm like, all right, now I got to take 9 hundredths away from the 50. And I went, wait, I can't do that. So what I did was I mentally rounded up to 10, took that away. That would give me 1 and 40 hundredths. And then I added the 1 back in.
And then what did that give you as your final answer?
1 and 41 hundredths.
Okay, I'm almost there. I just think I have an error in something that I wrote.
You do.
What was
I
it?
rounded up to 10.
Mm-hmm.
We're really, okay, not exactly 10. 0.10. Again, learning how to describe exactly what I'm doing correctly.
Okay.
Took that away from the 1 and 5/10, which gave me the 1 and 4/10, and then I added back the 100th.
So it wasn't the 900ths, it was the 100ths?
No, it was a 100th, right. Thank you for bearing with me. I have to do that with my students sometimes.
I love that you were patient with me also. And let's see, I noticed that there are some yellow colors, some green colors. And so I think there might even be one more way out there. Let's see, Lisa, did you have another way of thinking of it?
I just thought about when I used to be a campfire leader and we would do like Girl Scout cookie sales, but candy sales. And I had to teach my children how to count back change correctly. So I thought of it as 59 cents, then put a penny to get 60 cents and continue up. And if I were using change, I would go 60 cents, 70, 75, add a quarter to make it go to $1 plus another dollar to get to $2. Or if you just went from 59 to 60, 70, 80, 90 to 1, then jump to 2. That would be another way to make change. But definitely use money.
And I'm going to just keep these strings of numbers here because I thought that was such a clever way that you didn't even say like plus, minus. You were just kind of like counting up the change. All right,
I think
folks.
Go
ahead.
Kids don't have anymore. It's a skill our kids don't have anymore. They just don't see it used much.
Yeah, Yeah, so let's get into some change today. This is how I do number talks online. It follows a lot of the same things that are done in the face-to-face setting. I do love to use color whenever possible. On slide 7, I've got my protocol. I really want students to share their solutions. Some people did in the chat box, some did over the mic. And it's always fun when we have this back and forth in the chat box. Raha, go ahead.
I had a quick question about what if your first student was trying to defend a wrong answer?
Oh, that would be such a great one. I did want to see that on here. So we could look at the number talk protocol where we would want to put their thinking up there. But much in the same way that I put some stuff up there and then I asked Colette, like, I think I did an error in writing this down. Oftentimes when I have the 4 ways up there, I'll say, well, it can only be one right answer. How do we figure out what the right answer is from all this great thinking? And I always recognize that almost every time, even in wrong answers, the thinking is right. There's just what we used to call the careless error, or there was a forgetting to bring the 1 back, or thinking 0.01 but writing 0.09. And so what I try to do is value the correct thinking and then say, like, which number here needs to be changed so we have the right answer. And we really focus on ideas rather than people.
Thank you, Teresa.
Yeah.
Teresa, can I also point something out really quickly?
Yeah.
This is Sonal. Very cool. One of the things that we do in Piscataway quite a bit, we work with support specialists to dig deeper and see what's going on when a student can't subtract the 0.59 from 2. And we find that in a situation like that, quite often the child can't do 100 minus 59, let alone the 2 minus 0.59. So then we go back to counting by tens. And so if we did 100 minus 60, how that sort of lands to, you go back 60 and then add 1 and then relate that idea to 100 minus 59 and then eventually work up to the 2 minus 0.59.
Yeah, and I think that there was a lot of neat connections over here with Lisa's model and just kind of counting that money. But the nice thing about this routine is you can just do a real quick, like, here's the way Lisa did it, here's the way Dan did it, here's the way Meg did it, here's the way Colette did it. And then students will, if we do this every day, they start to make these connections of like, oh, I could subtract this first, I could add that second. And that's the beauty of this. Not that this one occurrence is the way that it's always done, but that by doing it each day, each week, that students start to get flexible in how they decompose numbers, how they do repeated addition, multiplication, division, and more.